It's called matter. Okay. None?
Done, sir.
Now you know we have divided this one into two parts in a physical state of matter. Physical state of matter. One is solid, another one is liquid and gases. Okay, so we are going to discuss each and every one in detail. Okay, Rumaisa, why you turn off your camera? Amal, Abdul Jabbar, Mohammad
Yes, sir, I don't have
Riaz.
a webcam, so I have to buy a webcam today, and from tomorrow I'll start turning on my camera. So
Okay. So because there should be an eye contact between the teachers and the students so that I can teach you. The face
yes, sir,
expression
just
is
give
very
me today's
important, whether
time and
you
I'll
are
turn on
getting
my
me,
cameras.
if you are listening to somewhere. Sometimes I'm just teaching you, okay? But I can see you that you are not listening to me, you are looking somewhere. So I can say that look at me. Is what I'm there, what I'm saying. Concentrate again. Okay. So this skills are very important. Okay. So turning on camera will help a teacher efficiently teach you. Okay. So this one, let's move further. Solid. One is solid. Let's start. Solid. What are solids? You know that solids are the substance or the matter that consists of particles. The particles, you know, every matter is made up of particles. And here the particles of solids are very, very closely packed to each other. Okay, they are tightly packed. They have very, very small intermolecular space. They have the molecular space, but they have very, very small. As comparison to liquids and gases, there is very, very less. Like we have, you can see here, this the intermolecular space is present here. Intermolecular space is present here, but this is very, very small intermolecular space is present. Okay. So we can say that in solids, the intermolecular space is very less. Okay. And the particles of solids are tightly packed. Okay. And they are not moving. You can see that this particle will always remain here. It will not be going to take the place of this one. And this particle will remain always here. It will not coming here. So the particles have their fixed position and they have very less intermolecular space. So we can say that the particles of solids are tightly packed with very, very less intermolecular, very less intermolecular space. Okay. Got it? Second, the particles of solids have fixed position. They are not moving. So they are not moving. They have very less kinetic energy. You can say they don't have kinetic energy. Particles of solid have fixed position, i.e. they don't have kinetic energy. They don't have kinetic energy. They don't have kinetic energy. The kinetic energy is not present because they are stick. Kinetic energy is the energy due to motion. If something is moving, then it is going to have the kinetic energy. But here you see that particles of solids stick together. They are not moving anywhere, so they are just placed at the single position. So we can say that the particle of solids are fixed and they don't have kinetic energy. Got it? They have very less intermolecular space. Okay, they have very less intermolecular space, and moreover, you know that if they have the fixed. Okay, now you know that they are incompressible because there is no space. If something can be compressed, this particle can be compressed by applying the force, and they can come and they can be brought together by applying the force. But already there is no space here. There's no space. Particles which are going to have a space, they can come closer to each other. They can come closer to each other. But if there is no space already present here, so what can we say simply? We can simply say that the particles, the solids are incompressible. Okay. So we can write here solids are incompressible. Particles of solids are incompressible. Why? As they don't have intermolecular space, or have very, very less intermolecular space. But the particles are tightly bonded together. Okay? We can have so many reasons. The particles of, of solids are incompressible. Okay. And since they don't move anywhere, so they have the particle of solids are fixed at their position. So they have fixed shape. So we can say that solids are incompressible and have fixed shape have fixed shape and fixed volume and fixed volume. What do you mean by the word volume? Volume is the space occupied by anything. Space occupied by anything. By anything. Okay, for example, if you have a gas particles, okay, and you put a nozzle here, okay, there's a gas particle filled here. So they will going to occupy the whole space. Okay. Now, if you transfer this gas into a smaller cylinder, then they will come closer to each other. They will come closer to each other. Now, this container is going to have this gas from the bigger container come into the smaller container. So they don't have fixed volume. Means the gases don't have the fixed volume because the particles have space and they can be adjusted. But in case of solid, if the particles are already very tightly bonded together, and their particles means you cannot compress it. So if you cannot compress it, so the particle cannot be bended. Okay, we can simply say that there is no space, so you cannot compress it. And if you can't compress it, there will be no change in the volume. Okay, so change in the volume occurs if you can compress something. For example, if you are having a glass of water, okay, if you have a 1 liter of water, 1 liter of water in a bottle, okay, 1 liter of water in a bottle, this is 1 liter, and this is another bottle that is of 500 ml. This is of 500 ml. 500 ml. So can you pour this 1 liter of water completely into this 500 ml bottle? No. Can you, Abdul Jabbar, Haris, can you pour this?
No, sir.
This 1 liter of water into this 500 ml?
No, sir.
No,
No, sir.
because half of the bottle will get filled, you are going to have half 500 ml water remaining. So this is a simple case that we can simply say that here that 500 of means solids have fixed volume. It means the space occupied by anything, that is called volume. So since the particles are very tightly bonded together, they cannot be adjusted further because they don't have a space, so they have fixed volume. And why they have fixed shapes? Because the particles have zero kinetic energy. So every particle is going to have its fixed position, so it cannot adjust its position. So we can simply say that particles have fixed shape. Particle of solids have fixed shape. You understood? Everybody? Amal, you understood? Rumaisa?
Yes, sir. Understood.
Yes, sir.
Riyaz?
Yes, sir.
Riyaz, why you turned off your camera? And Rumaisa,
Yes,
you
sir.
also? You are in the focus mode. We check. Yeah, you are in the focus mode. Nobody can see except. Okay. So don't think your video is going to go in by no. This will save. We are just going to have a company. Okay, that is not going to. Okay, so let's start further. Now the first one is. Again, I'm just writing. Solids are incompressible. Solids have fixed shapes. The particles are tightly bonded together. They have large amounts of attraction. Okay, and the volumes is fixed. So that's all about the solids. Okay. Now moving to the liquids. Okay. So we can say that particles of liquids are continuously moving. We can say the particles of liquids are continuously moving. So if they are moving, particles are continuously moving. So what does this mean? Maisa, what does this mean? That which type of energy it is going to have?
Kinetic energy.
Kinetic energy. Okay. So if the particles are moving, they have kinetic energy. If something can move, so it can adjust the shape now. For example, if this is something, for example, if I'm having a something like that can change its shape. So if I'm having the bricks like a structure, and these are the bricks. So if you can adjust the brick, for example, you can place this brick here like this way. Okay, so you can change the shape if these bricks are adjustable. Similarly, if these particles are adjustable, the Jabbar has gone somewhere. That's why I'm just saying every student must turn on something. Okay. So if I'm saying liquids, so liquids have in liquids particles are continuously moving. Abdul Jabbar, may I know that where you left the why you left the class? Means why
Bring
you
a
left?
bring the
Yes,
book.
to bring the books. Did you ask me?
Yes.
You didn't ask me, na? If Nick, for the next time, if you leave the chair, then you have to ask me, okay? Study like you are studying in a class. Don't think that it is an online class. If I can see you and you can see me, then it is a simple class. In liquids, particles are continuously moving. In liquids, particles are continuously moving, i.e. they have their
Kind,
kinetic,
kinetic energy.
they have their kinetic energy. Okay? They have means particles. You can say the particles, i.e. the particles of liquids have kinetic energy. Note it down.
Sir, in message you wrote biology class.
Biology class we have done previously.
Okay, sir.
Today was biology class, but here it is in my message it is chemistry class. So I did chemistry class.
In message you wrote biology class.
Okay, this is a mistake by the. Let me check the message again. It is in my message. It is written chemistry. Okay, so let it be. You must tell me first before the class start. But you didn't. So why you start teaching chemistry? I have to start teaching this one. 15 minutes has been passed, so let's continue this chapter. In the next class, when we're going to have chemistry, then we'll teach you bio. Okay.
Okay, sir.
Okay. Okay, let's start. Let's move further. So if I'm having the next point is about these liquids. Particles are continuously moving, so they can adjust themselves into any shape. So we can say that liquids don't have fixed shape. Okay, they have intermolecular space, molecular space. They have intermolecular space. Space again. Next. They can flow. Liquids are not compressible, and they don't have fixed shape and they are not compressible. If anything can't be compressed, so it is going to have say fixed volume. Okay, So we can say that they don't have fixed shape. Why fixed shape? Because the particle can adjust themselves. So if they can adjust themselves in any order, so we can say that the position of the particle is not fixed. So it can let the means liquid can take the shape of any substance, okay, in which the container they are for. But here, if I'm saying why they have fixed volume, but have fixed volume, volume case is the occupancy. The occupancy is that if they are not compressible, liquids are incompressible, or we can say liquids are not compressible, or we can write liquids are incompressible. Liquids are incompressible. You can write anything incompressible. So you can't compress something. If you can't compress something, you cannot change the volume occupied by space occupied. How can we change the space occupied? If it is compressible, if something is compressible, you can change the volume. If something expand, something compress, you can change the volume. Okay, but if something can't be pressed, so how can you change the volume, the space occupied? So you cannot compress it. Okay, so if they are incompressible, so that's why they have fixed volume. Okay, the third one is, okay, got it. Abdul Jabbar, please place your lid of your laptop a little bit like this slightly, okay, so that I can check your copy also that you are writing or not. Okay, yes, like this. Right. Now moving to this one is next. Don't fix volume and intermolecular space is low. The one important thing is liquid can't fill the container completely. So liquid can't fill the container completely. So note it down, note this.
So what does the fifth one mean?
Hmm? What are you saying?
The
Speak a
fifth
little bit
one.
louder.
Liquids can't fill the container completely.
Why liquid can't fill the container completely? Hmm?
Yes, sir.
Because there is always there's a property of liquid particle that they attract something. They attract each other. Okay. So there is always a little bit of small space left that liquids can't fill that one. Okay. When you cap it. So that's why because of the force of attraction between the particles of liquids, large force of attraction, they can't fill the container. There is always an air bubble thing. Okay. Done.
Yes, sir.
Now
Yes,
moving
sir.
to the next one is gases. Properties of gases. You can simply say that liquids, sorry, gases in gases, particles have large intermolecular space. Second one. Second one is they are compressible. Are compressible. If something can compress, which property is not constant? Shape or volume? Iris, tell me. Something is not constant, then which property is not constant, fixed? You first unmute the mic and then a little bit later, then you speak. Now you speak.
Sir, what do you mean?
I'm asking that if something is compressible, so something can be compressed, then which property is not fixed? Shape or volume? If you have this particles, okay, and they are just occupying this space. If you compress it, when you compress it, it can become into this container, okay? So this container is large, this container is small. So what is the difference between now? Same amount
They
of
are
gas
highly
is,
compressible.
they are compressible. So what is constant? What is not constant? Volume. Here the
Yes.
volume, they are occupying large space. They are occupying
Yes,
large
sir.
space here in this container. But here you see that they are occupying less space. Same gases are occupying less space. So more space, more volume, less space, less volume. Got it? Because they are highly compressible, so we can say that they have, i.e., they don't have fixed volume. I'm saying particles are continuously, particles have high kinetic energy. Particles have high kinetic energy. Note it down. So done. Rumaisa, done.
No, sir. Just a second.
Particles of gases, and they have very large intermolecular space. They are compressible, so they don't have fixed volume. Particles have high kinetic energy. Okay.
Done, sir.
Okay. And unlike the liquids, gases can fill the container completely. Gases can fill the container completely because they have very high kinetic energy and very less force of attraction. Why they can fill? Because they have very less force of attraction between their particles. Okay, you understood?
Yes, sir.
Now do question number question number. Now the point number 5 is gases can fill the container completely. Gases like the liquids, liquids, gas can also flow. Okay, so the things that can flow is called fluids. So we can say that both gases and liquids are called fluids because they can flow. Okay, done.
No,
You
sir.
understood, Abdul? Amal, you understood?
Yes, sir.
Okay. So have you noted this one? Okay.
No, sir.
Okay.
Done, sir.
Sir, done.
Done. Is my meeting? Okay, screen is visible to you now? Okay, now moving to the further, I'm just going to have. So now there's a question that comes in examination that we know that a sponge is made up of solid. A sponge is solid. You say though the sponge shape is particular, but we can compress it. So how can we compress it? So here's a question. If sponge is solid, then
Sir, because sponge has minute holes.
And that
How?
minute holes, they trap air, and when they are compressed, the air is exerted out. So we're able to compress.
Yes, exactly the same answer. By the sponge, if the sponge is solid, they can. Then why compress it? Okay. Done. So note
Yes.
note the answers in the copy in your own words. Then I'm going to ask you. So I'm going to tell you that because just check. You have to note the answer by using these words. You have to note the answer by using these words. I mean, these words should be in your sponge, air holes, compress, air rushes out. Can be compressed up to certain limits. Okay. Okay, don't write it. Don't write it. Okay, don't write this line. Okay. Now write the answer by using sponge, air holes, compress, air rushes out. So you have to use these words in your answer. And I'm going to ask you that what should be your answer. Okay.
Done, sir.
Done.
Yes, sir.
Okay. So what's your answer? Read it out.
A sponge has minute air holes in which the air is trapped. So when the sponge is compressed, the air trapped inside rushes out, so we're able to compress it.
Okay, very good. Abdul Jabbar, what do you write the answer? Abdul, what's your answer? Please speak. First, unmute your mic.
Yes, sir.
Yes, right. Have you written the answer?
No, sir.
Aris, have you written the answer?
Yes, sir.
So speak.
Sponge has minute holes in which air is trapped. when we compress it, the air is expelled out, and therefore you are able to compress it. And
Okay. And you, Riaz, have you written? First unmute your mic. First unmute your mic. Then
Yes,
speak
sir.
now. Have you written the answer? Speak your answer.
No,
Read your
sir.
answer. Read it.
No, sir. I didn't get the answer.
You didn't get the answer. Amal,
Yes, sir.
have you written the answer? Amal,
Yes, sir.
what's your answer? What's your answer? Read it. You have to use these words. Have you written? Okay, note it down. Note it down. Note it. Note it.
No, sir. Done, sir.
Okay. Similar is for the rubber also. Okay. The rubber can be pressed. You can say that rubber can be extended. You can say that it can change the volume also. Okay. So why the rubber particle? Rubber is solid. How can it extend? How can it change the volume? It cannot change the volume. Actually, when you scratch it, it become thin. It become thin. Okay. So rubber band become thin. So space occupied will be same. But here we can say that there is an air holes present in the rubbers also, and that's why we are able to bend it because okay, the rubbers are able to change their shapes. Okay. Now moving to the next test. The correct characteristics of particle of matter. Of particle of matter. The particle of matters have some characteristics. What do you mean by the characteristics? The word characteristics.
Its features.
Yes, its features. So just for example, if I'm asking you the what is the characteristics of a computer? So you say that it must have some screen, but have processor, keyboards. Okay. So the characteristics, similarly, characteristics of the particle of matters. How does it behave? What are its features? It's called characteristics. Okay. So we can say that particles of matters have following characteristics. Particle of matter. Particle of matter have following characteristics. One is a
Particles of matter have space between them.
particle of matter. Particle of matter and space between them. Second, how can you prove this activity? Particles of matter have a space between them. How can you say solids? Do solids also have a space between them?
So when we dissolve any, for example, if we dissolve some sugar in water, the particles of sugar gets mixed with the spaces between the particles of water and they get dissolved.
Yeah. So if I ask you a simple question, do the particles of solids also have a space between them?
No, sir.
They have. Particles of solids also have a space between them. But you know very well, we need to convert it into the, for example, if I'm having particles of iron, these are the particles of iron. These are bigger in size. Okay. We just change when we change this when we make it convert it into steel. So we add some carbon to it, and the carbon particles are small in size, so they can come into this space. Okay, accordingly, so they can come into this space. So similarly, the particles of matters means if I'm saying solid, liquid, and gas, solid particles as compared to the liquid, the particles in this intermolecular space in solid is very less as compared to liquids. Okay, so we can simply say that we can give an example of this one for better understanding. The particles of matters have a space between them. So how can we say? If we take a suppose this activity can be proved. For example, if you have some okay, this is a glass okay, and it is having some water inside it, and you add a two to 3 tablespoons sugar into it. Pour sugar 2 to 3 tablespoon sugar into it. Okay, so initial levels you mark it this one, the initial level. Initial level. Okay. Now again, if you are having the same okay, so initial level is this one. So after adding some water to it, when you add some water to it, sorry, some stable tablespoon sugar to it. without dissolving, like sugar particles. The sugar. Okay, so suddenly you will see that some of the level will get raised. Okay, some of the level will rise. Rise in level. Rise in level. But when you dissolve this sugar, after dissolving, you will find that the level reaches to its original value. The level reaches to its original value. After dissolving, the level reaches to its original value. Okay. Original levels. After dissolving, we can have before dissolving. Okay. And here we
Yes.
have. Okay, so got it. So make this three first. A, B, C. Mal, are you writing?
Yes, sir.
This one.
Done, sir.
Done? Okay, let's
Yes.
start. Let's start. If I'm saying particles of matter have space between them, this activity, this characteristics of particle can be expressed can be proved proved by this activity. Take some water in a tumbler and add tumbler and mark its level. Now add 3 to 4. Now add 3 to 4 tablespoon sugar to water. You will notice the level of water rises. Now start dissolving. before dissolving. To mark this point, the level of it is just to solution level. This indicate the sugar particles goes into intermolecular space of water. Write down. Done. Still writing.
Yes, I just
Done, sir.
Okay, tell me the particle of matter are continuously moving. How can you say that the particles of matters are continuously moving? Anybody in the class can tell me how can you prove that at this activity the particles of